Hello everyone. So this is the first video in the mock interview series. So in this series, I will try to do some mock interviews with my friends. So they usually work in large tech companies or like financial institutions like Google, Facebook, um, or like myself working in hedge funds. So something like that. So we are quite experienced in the interview area, I would say. So I myself has been interviewed for like hundreds of times already, and I've been interviewing other people plenty of times. So we will try to give you like a feeling of like what's a real interview like. So one of us will be the interviewer asking you a couple of questions, and then the other one will try to answer the questions like on the line, and then there will be like some like feedbacks in the end, and then like we will try to summarize like what's happened. So in this one, so my friend at Google who works in Google, and he interviewed me for asking about these questions, which is seemingly easy, but like there are some follow-ups, and then you are just going. I'm going to try to solve it on the fly. So I have never done this in this before actually. So like I don't think I have ever done this one, and there are some follow-ups which I definitely have not done in my spare time actually. So this is me doing it on the fly. So my so I hope you can learn something from this. So like as you can say how I approach this problem, like how the mistakes I made, and then like how I listen to the interviewers um, uh, hints, and how I stir my way into like the right direction, and then how like there will be like some like a discussion of like what's the in the end like there will be some discussion on like what can be improved. So I hope you enjoy this, and if you find anything interesting, please let me know actually, like let me do and then like please comment, and please let me know your thoughts. So if you want to do any like mock interviews, please just comment below, and I will contact you actually. So I think like this is a great form for both of us to learn, either being the interviewer or the interviewee. I think it's a great way to learn actually. Thanks. Okay, so we are going to do a mock interview. So my friend will give me a problem, and then we'll do it like in a formal setting. So like we will just pretend this is a coding interview. And
Okay,
then
sure.
yeah.
So the problem itself is going to be very simple, but I want to see how you approach it.
Uh-huh.
And perhaps we should try to optimally give multiple answers for different requirements.
Okay, sure.
So the question is, by the way, are we using just a text editor?
Okay, sure.
So I'm giving you an immutable linked list, singly linked list. Can you try to print out all the values of each node in reversed order? Reversed order.
So the first thing come into my mind would be
Okay, give me 1 second. I can give you some APIs to work with.
okay, sure.
So basically, there's you cannot touch the underlying data directly. You can only use the APIs.
So let me write down the definition of this actually, the definition of the function we are going to implement. So I'm going to use Python if that's okay with you. So so we are going to say print inverse print reverse linked list, and you are given a node which is immutable node, right? And then you are going to, so this doesn't return anything, so it should print out the linked list in reverse.
Let's just name it head.
Okay, sure. So what will happen when you call the get next? I assume so. I assume when you call get next, so it will return you immutable
Right.
list
It
node.
gives you the next node.
Yeah. And then if you have now or none, right? So like if like you have not you don't have any more list node, then it will return none, right? Is that assumption
Correct?
Yeah. So
yes.
So I think the very naive way to do this actually, the first thing coming into my mind is if we are allowed to have use extra memory. So I would think we can just allocate a new list, a Python list, and then we will just call the get next in a while loop and test if the value we get from the next is null or not, is none or not. If it's not null, then we just push it back to the list, and then in the end we just return reverse. We just reverse that list, and then we just call the print value in a for loop or in a while loop, and that give you the results. Does that make sense to you actually?
So can you tell me what is the complexity?
So the time complexity is O(n) because you are traversing the array, the list once, right? And then because appending to the end of the list is O(1) operation, so you are actually doing O(1) operations in total. Although you are traversing the list once, you are reversing it and then you are printing it. That's but they are all O(n) operations, so like they just in total you are just doing O(n), although you have a three you are doing three O(n) operations, but the time complex the memory complexity would be O(n) as well, because you are allocating a new list to record whatever you have in the array, so that's also dependent on your on your on your on your input size actually. So
Okay.
there's another thinking I have, which is to do this recursively. So you just go so you just go through so you have a recursive function, and then you go to the end first, and then you on your way back you print out all the values. That can work as well, which print out the values in reverse. So that's also O(n) in terms of time complexity, and then in terms of like memory. If you don't count the call stack, then it's constant. But if you count the call stack, then it's all O(n) as well. So like both ways it works, I think. Yeah.
So okay.
Mm.
My question then is, what if you have to deal with a very huge list? Your memory is going to be constrained. What are the options you have?
So you mean the list won't fit into memory? So
Correct.
like I cannot.
I hope to see a solution better than all of n space complexity. Right now, I'm okay to see even worse time complexity. Let's see what you can achieve best in terms of space complexity.
So that's so we can
I'm just going to type it here. Constant space complexity.
So I am thinking maybe we can go to, so we can have a pointer, so that goes to the end of the list actually, without recording anything. It will only, so one thing that comes to my mind immediately is like say if I have a list which is 1, 2, 3, 4, which goes to say a very large number. So let's say it's 1,000,000 probably, and then what I'm going to do is I have a pointer which goes to the which goes to 1,000 which goes to the last number, but we only have a constant. We only have a constant space, so we only record the 100 elements actually, and then so we only record the last element, the last 100 elements we have seen, and then but that doesn't work because you need to remember what values you have seen. Let me think about that. So so I'm thinking, so the general thoughts I have would be how think of a way to chunk this into smaller chunks to divide the linked list into smaller chunks and deal with that linked list, deal with each chunks one by one in a reverse order. That's my thought at this moment. But the problem is like we don't know how large is the array, so it can be difficult for us to determine the chunk size actually. So if we can easily determine the chunk size, then it will be easy to do. You just pre-allocate a number. So say if I can determine like I can each chunk will have only n elements, and then I will have m chunks, and then that will add up to the total size of n times m, and then I can deal with the list actually. But so I think then, given this, I can think of a way to do that. So which is you need to first count how many how you need to count how many elements you have. So you need to first count the number of elements in your list, and then you need to be able to divide the number of the list into so into array into smaller chunks which you can process in memory, and then you remember which chunks you remember how many chunks you have and deal with them in reverse order. Does that make sense to you actually? Like does that sound something reasonable to you?
What do you think is going to be the complexity?
So this step is definitely ON, right? So like because you need to be able to say how many elements I have in the array, and then so these, so you when the chunking size also like you need to go through the list again, at least to the last the beginning of the last chunk. So that's ON as well, and then also you are going to have ON. So then you have to go through each chunk and reverse them and print them. So that's all as well. So the time complexity is like that, but the constant space complexity, which So you need to say I need to be able to divide the chunk into. So I need to have a fixed number of chunks, which is 100 probably. Which is then you need like a 100. You just need to have 100 pointers pointing to the beginning of each chunk. And if you cannot do that, then but this will limit the total size of your the ability your number of items into 100 times the number of memory you have actually. So like the number of items you can hold in memory. So like this will have some limitations. It doesn't really guarantee you that it can reverse anything like any like infinite large array. It doesn't guarantee you that actually. So to how do we? So the question is like, how do we deal with like infinite large? My question asks.
It's not going to be infinitely large, but it can be a very large number. Let me repeat to make sure I understand your solution.
Yeah.
You're saying that you can divide this large list into a number of partitions.
Yeah.
Right.
Yeah.
The initial partition is going to take all of n times complexity, which I agree with.
Yeah.
Now, the exact number of partition, is that going to be fixed or not?
I think like we need to fix it. If we don't fix it, then you will have you'll have like then it will depend on the number of your inputs. Then your memory. So that will break the constraint we have, which is O1 constant space complexity actually.
Okay. So the number of partition is going to be fixed. Now the question is, what is the final time complexity? You're saying that it's going to be all of n?
Yes.
Can you go through the following steps so I can understand?
So what I'm thinking is, so for example, let's give you a concrete example actually. So like I don't know why it doesn't allow me to do that. Just give me a sec, sorry. So what I'm thinking is, if you have one, for example, if you have 1, 2, 3. So let's take this as an example. 1, 2. You have 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So my question, my thinking is like, so suppose you can only fit 3 elements in your memory. So what you are going to do is divide it into 1, 2, 3, and then you divide it by 4, 5, 6, and then you have 7, 8, 9. And then you reverse each one. So you reverse each one in memory, and then you print it out actually. So 1, 6, 6, 4, 5, 4, and then you do it 9, 8, 7. So you first. So you only need to remember 1, 3, 6, because that's the beginning of your each chunk, each partition, and then you're just going to say, so I'm going to go through my list, and then
147, right?
Yeah, 147. Sorry, I will just think. I will just go through my my list, and then once I see go through 1, and then I will remember everything I'm seeing, and then until I reach 4, I know like I cannot longer. If I go further, I cannot hold any element longer. larger element because my memory is kind of full. So I just stop and then I start reversing, and then but like in the reverse order. So you go to 7 first, and then you go back to 4, and then you go back to 1. But thinking about this is not really all one time complexity actually. So it's still not all one time complexity because you are actually using a lot of memory. So
Sorry, can you say it again?
sorry.
Can you say it again? The last statement.
So think about this because it's still not very it's not all one complexity because unless you
mean time or space?
Space. So the memory complex the space complexity. So if you don't fix the number of chunks, so that's what I mean before. So you need to say I'm only going to use 100 partitions, and then that can give you so then this array will become fixed, right? And then that's only when you say I'm going to use a fixed fixed number of partitions. Only then you can say this is all one time complexity. But if you are going to say I'm going to
hold on. I'm confused again. You said time complexity.
Sorry, space complexity. Sorry. So only when you fix the number of partitions you are going to use, your space complexity is all one. But if you make it dynamic, depending on the number of the input, your
right.
input.
That part I agree. I'm asking what is going to be the time complexity then?
So basically, first you need to come up with these partitions, right? Then that's ON, right? So you need to say
right. That's ON.
Yeah, and then for this one, so and then you need to go to the last one, right? So you need to go to the last element, the last chunk, the last partition, and then you are going to need to reverse that. So that's ON as well, right? I need to go to the last one. Oh, sorry, I see what you mean. So yeah, because you are going to need to I always travel from the beginning to each partition. So I think that's ON squared. Yeah. So that's the worst case scenario. That's the running complexity. It's you need to, because every time you need to say I start from the beginning, I go to this partition, and then I reverse, and then I need to start from the beginning, go to this partition, and then so basically you have a double for loop, and then that's ON squared time complexity.
Let me think. Every time you have to start from the beginning.
Yeah.
But you already have this list of the nodes, right? Why do you have to go from the beginning?
Because linked list is not like a random access, so you cannot say I remember I'm going to the first linked list, right? I need to say I need to find that. So suppose say you are done with the partition beginning with 7, then you need to kind of go back to the beginning and then find this partition, the partition with starts with 4 in a double for loop actually. So
well, you can already save a list of the nodes, right? You can save nodes to 1, 4, and 7. I'm missing. Then yeah, you are right. So you can go to the then it's still ON, right? So if you don't need to do that, then it's ON. So you just need to say I need to go to the last element. I need to go to 7, the element will start with 7, and then you need to reverse that. So that's an ON operation, right? So you just need to go to the last one, and then you go back to the beginning. Because I'm thinking you just do it. Can you okay? Let's just focus on the last chunk. from 7 to 9 or whatever number that is. How do you reverse this using constant memory?
You need to use a counter, I think, like because because at this step you need you know like how many, because you know like there's like a 9 elements, right? And then you know I have 3 chunks. So here I know like I have 3 elements. So you use a chunk counter. So you start from 7, and then you go to 8, and then you go to 9. So every time you decrease, right? Like you decrease it to 3, 7.
Okay.
And 2 is 8, and 1 is 9.
Okay.
So you use I
agree with this part.
Yeah.
So within each chunk, the time complexity is going to be n squared.
Yeah, I agree. Yes.
Right?
Yes.
So then my question is, do you still need to divide it into a constant number of chunks?
No, you can do it with the whole array. Then like you just need to remember. Like
you can just use the counter method you just said, right?
Yeah.
You still get the same time complexity. You get constant memory, and it's easier to write.
Yeah.
Okay, sounds good. Do you want to do that?
Cool. So we can implement this actually. So like I'm going to implement this counter method. So there's a couple of things I want to mention. So like before we go into that, so I'm going to assume that we are using Python. So I'm not overly concerned about like an integer overflowing, like because you mentioned the list can be very large, right? So like I don't really think. Because if we are using say Python or say, then there might be overflowing. But like because I'm in Python, I'm not going to concern myself with that.
So let's just assume everything is reasonably good. Don't worry about overflow. Just do it fast, because there's going to be a follow-up.
Okay. So let's think define counter. So I'm going to do it with 2 with like another smaller function, which I think would be helpful. We count number of items, so that will have a hide node, which you are going to give it a node, and then you pass, and then so this will return you a integer basically, and then I'm going to implement it in a bit, and then so what you are going to need to do is so for I so your counter so number of items equals count number of items had, and then so for I in so you cannot easily do that actually. So while so you start with the current item actually. So the current item equals the number of items, and then you do it while so starter so counter equals 0, and then you do while counter is not equal to current item you should print out. Then you do so you need a node actually. So you need so you need another count actually. I think you need a printed items. You start from 0. So while printed items not equals to the number of items, you set your current counter equals to 0, and then you do while your counter, and then you do your node equals head to get the head, and then you do while counter not equals to current item, you do node equals node dot get next, and then you do, so this will get you to the correct item actually, and then you just do node dot print value, and then you do node you do your current item minus equals 1 to decrease the element actually, and then so that will print out the list in reverse actually, and then this part is easy to implement, I think. So you will have a counter equals 0, and while so node equals head, and while node not equals to none, you do node equals node dot get next, and then you do counter plus equals 1, and then you just return your counter. So basically, so these will, so basically you are counting the number of nodes, and then you set your expectation. So you set your expectation to be the number of nodes, and then you count your printed nodes. Here I need to do printed items plus equals 1 as well. So, and then you count how many numbers you have printed, and for each loop, inner loop, you just move your item into the expectation actually to the current item you should be printing, and then you decrease that number each time, and then you increase the printed numbers actually. So this way you keep track how many numbers you have printed, and then you can just this will print out the number of the whole list in reverse actually. Does that make sense to you?
I'm looking through the code. There's I see a bug.
Mm-hmm.
Can you find it? I see a bug in the loop in your main function.
So counter plus equals 1. Yeah. You need to increment the counter. Yeah.
Okay. Okay. Next question. Next question. Follow up.
Yeah.
What if I want better than all of n space complexity and all of n time complexity? Let me just rephrase it to avoid confusion. I want this. Do you think it's doable?
Let me think about this. So I think we need to go back to the chunk idea actually. So
okay.
Yeah, so I think like if we can divide each elements, divide the whole list into like n smaller chunks. So m smaller chunks. So suppose like we have n elements in the linked list, right? And then we can divide it into partitions basically, right? Chunks. So we can do so if I'm going to write it down then So we can actually reverse one chunk in O m time with O m with OM space, right? So like that's doable.
Right.
So usually I think like if we can so the tricky part is like if we so basically what I'm saying is, so if we go back to this example here, we can use OM, we can use only OM OM to memory to reverse this chunk, and we don't need to even remember anything about this, right? So this so basically here this part you can just reverse it with OM, and then you have some additional memory to remember the IM chunks, right? And then basically your whole total memory cost is OM, and then your total complexity would be ON, because you just need ON time to divide this into ON chunks, and then you don't need to. So here you can just use OM time and space, and in total, then your total time would be O n, because your time would be n times so m times so n divided by m times O m, right? So like would equals to O n. Does that make sense to you actually? Like so inside this chunk, you don't need to do anything special. You just, instead of doing like whatever we did here, we just use like a normal m space time. So that will strictly help in this to achieve this space complexity and the time
Can you
complexity.
specify what is the meaning of M?
Sorry,
What is the meaning of M?
m is the sorry. So m is the number of chunks. So sorry, this is n divided by m. So you only have n divided by m items, and then you have m chunks to process. So
Okay,
this
what is the time then?
The time, sorry, the time so this is all space, all m space to process all the chunks, and then your time would be m times so this number, which is m times
Why is the space complexity all of M?
because for each chunk you only need to remember like sorry, okay, I'm wrong. So n divided by m, and then plus OM, because you need to remember how many chunks at the beginning of each chunk, right? And then you need ON divided by M. So this number will be smaller than ON actually. So we can do a proof, but like I think like it will be definitely smaller than ON. Yeah.
Definitely be smaller than ON.
ON, sorry. So it will satisfy this problem. So right. So
I would like to see example number. What do you think M could be? Can you write a value of M using an expression with N? Do you see what I mean?
Yeah. So basically, you are going to need to find so n divided by m plus m. So you are trying to determine like the number here. So I'm thinking this needs to be O log. So basically, you can use O log n, right? Like so, like the worst case scenario is you recursively reply this method, right? So if you see what I mean. So so say if I use m equals 2, right? Like then it will be O n divided by 2 plus 2. But that's not good enough because this is effective O n. But you can recursively divide each chunks into smaller chunks, right? Then you basically have a tree structure, and then in the end you will have O log n time complexity, right? And then plus you got rid of the m here, and then so you can recursively apply this this chunking method to each smaller chunks, right? And then in the end you will get only two elements, and then you just reverse them in a smaller. Does that make sense, chunks? Does that make sense to you actually?
I agree with 95% of your thoughts, except for the last statement. If you set here, if you're saying if m is equal to O log of n, am I correct? If we let me rephrase, if we set m equal to that, you're saying that the left hand expression can be reduced to simply all of log n?
No, I'm saying so I'm saying you have this large array 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I'm thinking instead of like so we can apply this method to this single array, but then you will have this basic complexity. But if you try divide this into a two smaller array, say one. So if you set your m to be 2, right? So and then you will have 1, 2, 3, 4, and then you will have 1, 5, 6, 7, 8, 9, and you do that recursively, and then it will be divided by 1, 2, 3, by 2, 4, and then this one will become 5, 6.
Okay,
7,
I see what you
7,
mean
8,
now.
and then 9, and then you reverse each smaller chunk actually, and then you merge it back, and then that's my, because you don't even need to merge it back, because in each smaller chunk then you are just printing out the thing, right? Then you don't really need that much memory. Yeah.
Right, that I agree. Yes.
Yeah.
Okay. Good. I can tell you, initially I was expecting an even worse solution for question 2. I was expecting square root of n, and which is easier to implement if you think about it, right? You don't even need a tree, right?
Yeah.
Set m2 equals to square root of n. That's all you need.
Yeah.
But I'm happy with the tree implementation because it's even smaller, so it's good.
Cool.
Yeah. Do you have any question for me?
No. I think like how like if you can summarize like your feedback like in a few sentences, because the whole point is we do a mock interview and then
No, I'm sorry, I cannot share feedback with you because I'm the interviewer. It's going to be processed internally.
Okay. Yeah, but like in general, like do you think is there anything I can do better, and like
you should try to take some time to think before speaking. You for this question, you were able to solve it in the right direction. But in the beginning, apparently you went into a wrong direction, right?
Yeah.
Right. And another thing is, if you think about it more before speaking up, it's going to be easier for the interviewer to understand your statement. Because sometimes I can sense that while you are speaking, you are trying to come up with words on the run, which is not good, right?
Yeah.
You used a lot of, how do I say, actually, those words like that, it's going to make the interviewer confused.
Yeah.
But I like your solution though, so I'm happy.
Thanks. Thank you. Cool. I think that's all for the mock interview actually. Cool. Thank you very much. Thank you.
Okay.
Cool.